All right, well, now it's time. We're going to move right along for our tech corner. Once again, we're happy to have Robert Bellinger, who's the product applications manager of industrial microscopes for Olympus America, in our studio, showing off Olympus's LEX OLS5000 laser confocal microscope, which is a non-contact, non-destructive 3D microscope. So guys, take it away.
Yeah, thanks, Mike. And so, Rob, like Mike said, we got a new microscope. This brand new microscope?
Yes, this is our brand new version of the LEX. This is the model OLS5000. It's our laser scanning confocal microscope, like you said. Some new features and advances in this system, kind of groundbreaking. First off, they increased the speed quite a bit in this new system, 4 times faster, so you're able to get your images and data quicker and scan around samples at much faster speeds. With that speed, they also increased resolution. So we're down in the single nanometer range for Z resolution, still capable of very high magnifications, up to 18,000 times magnifications.
Is digital magnification, or both optical and digital?
This is going to be optical magnification using the laser,
Okay.
And then it comes down to the optics itself. The LEX has dedicated objectives. Since we're an optics company, we have a whole new line of objectives for this system. Some long working distance objectives that are designed specifically for the 405 nanometer laser.
Okay.
So what that gives us is the ability to have more accuracy in our measurements across our entire field of view and use a broader range of objective lens options and guarantee and back those measurement values. So on top of all that hardware changes, they also improve software. It's a ground up software now, redesigned for simplified use and a little more powerful measurement capabilities and some automation kind of built into it as well. So I can show some of the software stuff.
For sure.
So to begin with, we also have white light imaging on this system, so it can do both laser and color imaging. So we usually start in the white light, and with the motorized stage option, we can create in the software now maps very quickly. And this map screen does a quick scan around of your samples. So if you have a large part, but you're going to be working at high magnifications, you might want to create a map of it so you can move to different locations quickly.
Okay, so what it was just doing is scanning and stitching together.
And stitching together just a quick overview map of your sample that you put under there, and you could keep going and stitch a larger area depending on the size of the sample you have. And this map is now your stage control. So if I want to move to a specific location, all I have to do is double click on that location and it'll move right to it. And
so this uses kind of a navigation.
This is the navigation, and in this map we can also set up to do stitching areas. So not only can we acquire a 3D image in a single frame of view, which I'll show today, but for time constraints we won't show all the stitching capabilities, but it's able to set up a stitching map on this image and go to all those fields and automatically capture the 3D data, the color image, and create one entire 3D image that you can
at a higher resolution.
At a much higher resolution. So right now we do the stitch at the low mag at our 5x objective, but we can magnify in quickly to say our 20x objective, which now incorporates our LEX dedicated objective, and it does a quick autofocus to find the best focus point on our sample for us. And as I scroll through on the mouse here, this is just the live color image. I can kind of see where I'm located, make sure I'm on the right part that I want to inspect, and everything else beyond that is going to be automated in this new software. So really it's just this big start button down here on the screen.
So you define, I missed, you defined the start and the stop for the Z, or it's going to do it on itself?
This one's going to do it automatically with set in the auto feature. We still can go in and do a manual one for very specific needs, but over 90% of the samples, the auto is going to work. When I push this button now, and the software is going to do a smart scan. So you'll see it go through and capture a quick scan. It sets the bottom top of our focus, and it's also setting the brightness. Now what it's doing is scanning through our image, all the different platforms of focus, and building a three-dimensional image that we can actually interact with during the scan here. Zoom in and out. And as it builds this, you can see the sample come together. After this is done, it'll go back through and use the white light, since I have it selected, to capture a color image as well. And it'll build all of our focus points for color. So then we can take a high resolution laser image and overlay our color images on top. So if you're looking for, is that a gold pad or is that a metal plate at the bottom, you might know, rather than, a laser image is all grayscale, but a color image will tell us where maybe our gold contacts are.
So if we can go to the screenshot here, Noah. So this is the color scan, or is this the overlay of both?
This is the 3D height data that it captured during the scan, and it overlays the color image
on top of it. Okay, so you got both there. Okay.
So
gotcha.
this image here is the raw height data just in a color scheme, and this is the raw height points plotted. And the top image here is what the laser would see back, the grayscale laser intensity image.
And the bottom is those combined?
And the bottom is just the height data combined with the color.
With the
image.
color, okay, gotcha.
So this is real quick. It auto-saves our images for us, and the user's going to then go analyze the image once they have it set. When I do that, it'll open up a separate software for analysis. Now that software you could be doing measurements on and then go back to the acquiring software, the data acquisition software, and go get another image while you're doing measurements or doing things over here. So when it drops our image into here, it shows the 3D image again, and this is our color image. We can also see the map image. But what this whole layout is a template that can be customized, and this is where some of the measurement repeatability comes in between users. If you want a user to always do a step measurement on the sample or a roughness measurement on that sample, you can have a predefined template for that sample. So right when the image drops in, it's dropped into the template where we have, on this one, a profile measurement. So as a profile goes across, I'll actually double click on this to open the view. We can plot profile lines wherever we want, predefine those in the template, and as I move you can see the profile change in the bottom of the screen here. And on this profile what we're doing is a height measurement between two different steps. You want to know how far down this is actually a solder bump that's been removed, so how far down is penetrating into the circuit. And they can add more lines, they can take more measurements, do width measurements in here, any kind of critical dimensional measurement on the surface. And out in the software program here, we have all of our measurement results. So we get our height measurements, our profile line drawn. We can even plot 3D images on the second page. So all of these are multiple pages that then can be saved as PDF or Excel documents.
Now, if I understand, one of the real strengths, or one of the big strengths of this product is surface roughness?
So that's one of the major components to the software, and it's a surface metrology tool. So not only just volume measurements and step heights, we want to know surface wear analysis. So we can then go to line roughness profile measurements. So plotting a line somewhere on the sample image here, any location you want, we can set up to do roughness analysis across that line. So if you're looking at a groove or a wear analysis of something, you plot a single line point across that. And that gives you your roughness average measurements or your root mean squareds. And you can even get all the information out of like your waviness profile, your load curves, and all that information. So all this gets exported out into that same report document. Beyond just line roughness though, since we have an entire 3D area, we can do area roughness as well. So we can take an average around an entire area. Now on this one I've selected a region of interest on the sample here, on this one level here, and we was able to get area roughness measurements. And that gives us, surface area averages, and it's very quick because you've already got all the 3D data there. You just need to specify the region and it gets all the data for you. You don't have to scan multiple lines. And like I said, all of this template is customized. If these are the measurements you want to perform each time, right when the image drops in, all those measurement tabs are there. The most the operator might have to do is generate a new region of interest or something like that. And then everything exports out to Excel or to PDF documents for the measurement outputting. And like I said, as we're doing our measurements here, we could have went back to the data acquisition software and been capturing images. Sometimes we'll set this up with dual monitors to improve your workflow.
Now, I think you wanted to point out something about the objectives, or?
Yeah, like I said at the beginning, we have a new 10x objective, new long working distance objectives, a total of 6 dedicated objectives now for this microscope. So using the laser wavelength, we want to make sure it's optically corrected for that wavelength. So all of our measurements are repeatable and accurate through the entire field of view, even in a stitched image now.
Right.
So we can guarantee our measurements on this tool. So being an optics company, we don't just use off-the-shelf optics. We make the optics for this metrology system, and we're one of the only ones to do that.
What markets is basically this intended for?
Yeah, it has a broad range. Obviously, you know, like a circuitry chip like this, semiconductor markets for quality assurance or maybe even failure analysis, through to, you know, metals, any kind of metal manufacturings, bearings and valve manufacturers. And then it's moving into the automotive market as well. There's a lot of demand for the automotive market, looking at wear analysis and engines and transmissions. But like we mentioned earlier in the show, the electronics part of the automotive is really starting to blend in now. We're seeing a lot of electronic merging in the automotive market, and a lot of electronic imaging and failure analysis and quality testing done with this kind of tool. So everything from your smart cars now and looking at batteries to the sensors and the variable valve timing sensors and engines. They're getting super technology driven.
And is this the only size volume?
No, I'm glad you asked that. This is actually our small frame with a motorized stage. We have a large 12-inch frame system as well for a 300 millimeter, almost, you can fit large wafers onto that system. And then there's also a larger frame extension for this for very tall samples. They have a larger platform that can fit up to, you know, 300 millimeter tall samples for bulk stuff that you have to put on. Maybe an entire piston assembly needs to be sat under there for measurement at the surface. So there's an extension platform for that. And there's also the ability to hook this into gantry systems and such.
Okay, terrific. Yeah. So Rob, this was the OLS5000, right?
The OLS5000.
And there is a link to this, underneath the player page, there is a link that I believe goes out to the product data page for this. So if you want more information, you can go out there and look at it.
Yeah, please.
Okay, Rob, thanks.
Thank you very much, Dirk.
Okay.